welcome to this little crew cut here. We are looking down the microscope of Mike Kelly, and we're going to be taking a look at some thin sections. Mike, which ones did the crew suggest, or which ones do you have handy?
So I pulled out all the things that were pre-selected. People wanted to see Isheyvo, Namous 001 Angrite, one of the Lunars, 15373, Tiglet, Chelyabinsk. We got Muskogee, Plateau du Tademait, shergottite,
Nice.
Erg Chech 002. But I'll pull out anything y'all want out of the box, and we can just take it party through the slides. But yeah, let's take a look at some of the stuff.
Yep.
So who wants to see what first?
Tiglet.
Tiglet it is.
Tiglet.
So Tiglet's a witnessed Achondrite Aubrite.
So this is Tiglet.
Oh my gosh! Oh, I'm going full screen now.
Around. So the Aubrites are almost all enstatite, right? So enstatite, you're going to get a lot of these subdued colors for the most part. These cruise over here. You can see some second order there. Those are little bits of olivine in there. So you see like that second order green and blue spots kind of towards the 3 o'clock, 2/3 of the way over.
Mm-hmm.
Those are little bits of olivine crystals sitting in there. Try to keep it focused. We talked about good focus and good thickness on a slide, so you can see the edges are just as crisp as the middle. And if I move over across the entire slide, zoom obviously tries to keep focusing, but you can see it stays in focus until I get to the other edge, and it's the same all the way through.
Nice.
I think there's a little crust on here. Let's cruise around the edges real quick.
The first thing I'm noticing is the size of the crystals. Those large crystals, as we would expect with a enstatite-rich Aubrite.
Yep. And you can see no bubbles in the material. I did have one or two around the edges there, like that. You see that there? That's a bubble next to the piece. So that's all the stuff.
Is that black part that you were talking about?
Yeah, that black wood
okay.
is a bubble in the epoxy. You see the darkness around the edges. That means you're looking at it through cross-polarized light. Let's see. I thought I had some crust on here somewhere, but maybe not.
Crusted Tiglet, thin sections. Wow, you dirty dog.
There we go. Let me see here. Let me try.
Whoops.
So not a whole bunch of crust on there, but that is crust. That little fine line right along the edge there. And like Aubrite crust, it's a clearish to white, translucent to cream colored crust to it. And you could make that out in the thin section. And it's sitting next to a nice, decent sized olivine crystal sitting there. So you can see the enstatites are the lights, and you see those dark purplish pinks and kind of burnt orange there. That's an olivine.
Chelyabinsk.
This is Chelyabinsk, and what you're looking at right there is the transition zone. So over here, you have normal Chelyabinsk, and over here, you have Chelyabinsk-melt.
I love it.
Sweet.
Rivers
so
of melt.
Yep, and again, there's a pluck right there. It happens. I try to keep it to a minimum. And then if we move over here, you get some nice brecciation going on here. So you can see,
nice.
You can see the bits of the class in there, and following a shock vein along there. Here's some more breccia chunks in there.
Now, we were talking about this earlier without good audio. What are we looking at here?
Yeah, so that's a polysomatic barred olivine chondrule. And I know Greg was asking before about, things going to extinction at certain angles. So you can see at the bottom, it's extinct. But the other two crystals are only partially extinct. And as I rotate it, it changes which crystal is in extinction. Let's see if I can keep it in focus.
Oh, yeah.
Yeah, that's obvious.
So as you do 360 degrees of rotation at 2 points around that, a particular part of the crystal will go to extinction. And what we're seeing here are 3 different sets of crystal lattice for the olivine. And we're looking at these edge on, and they look like bars, but this is actually a stack of plates. And you can imagine cutting through the edge of those plates. And in a normal BOC, we'll see just 1 set of plates, but in these polysomatic ones, in this case, we see 3. I've seen some with 4 and 5 and even more than that.
Wow.
But that was Chelyabinsk. What's next?
All right. What's the next slide, guys?
Erg Chech.
Erg Chech.
Chech 002.
Erg
I'll be
Chech.
honest, I didn't think
Zero.
Shelly would be that pretty. I mean, it's not that
Ooh.
pretty.
Yeah, for an L6, it's got stuff in it.
Man,
That's cool.
That's
Let
crazy.
me check the
Wow.
focus on you.
Fabulous.
Like stained glass.
Yeah.
That's just beautiful, man.
Okay, so the big crystal, like there's a decently long one cutting across the center right there.
Oh, yeah.
Oh, yeah.
Not
but
the
yeah,
bright
they
green.
the bright green crystals don't pop so hot in cross-polarized. Let's see if we can go to plane here.
There
They don't,
we're starting to see
Yeah.
some green in it. Yeah.
yeah, they stand out a little bit more in plane. There's a decently long crystal on the edge there, cutting in.
Sorry. So I just wanted to backcast a little bit. We're looking at these in transmitted cross-polarized light. So we're illuminating the bottom side of the rock with polarized light, and then we're looking through another polarizer that's at 90 degrees. And so when Mike went to plane polarized, he rotated the top polarizer so that the 2 polarizers are in parallel. And so at that point, we weren't getting the cross-polarized light. We were just getting straight light through the slide.
Pyroxene?
Yeah, so those big crystals, like I'm following one across the piece here, is one of those green pyroxene crystals cutting across. This one's not huge, but you can see it traverses the whole piece, so at least this corner. But yeah, that's Erg Chech 002.
Wow.
Lots of olivine grains in there, and then those big long pyroxene megacrysts.
Definitely can tell it's volcanic. I mean, to a novice, a little bit. It looks more angular and chaotic than chondrites for sure.
Yeah, no chondrules in there, no round things. So this texture I consider this kind of subaphitic. You get some crystal grains in there, but they're not all perfectly straight lined crystal edges. It's kind of broken up. Some of them are rounded a little bit. The more round you get, those are called subuhedral. Euhedral would be all nice, perfect crystal edges. So, what's next?
Muskogee.
Muskogee was 4 or 5 days ago work.
Wow.
I think it's an L. You can see that the black opaques, those are all metal grains there. It's there, but there's not that much. You know what I mean? So I wouldn't say it's an LL. This thing had really bubbly crust.
Wow.
There's the crust to it there. I think I got a decent. That's probably the best chondrule in the whole piece. You could see, so it's probably a higher petrology grade, like a 5 or a 6. Because there really aren't a bunch of whole chondrules in there.
Mm-hmm.
This one would be a porphyritic olivine chondrule. So it's little individual crystal grains of olivine in there, not all aligned, all in random order. And those are kind of subuhedral too. Marissa had a great porphyritic olivine one where it was very crisp edges to it. So that would be a euhedral crystal. This would be a subuhedral. You can see they're kind of rounded off and all mushed together, and they kind of blend softly one into the other. But yeah, that's now the second freshest meteorite on Earth.
That is super cool.
It didn't hold that title for very long.
Yeah.
Sweet.
We have a request for Martian, and then whoever else wants to jump in can jump in.
Plateau, they gonna butcher it.
That's the new one.
This is Mark's new one. It did just get published. It does have big phenocrysts, and so what you're looking at right now is a phenocryst in the middle. You see all that gray material, and then it has a little bit of very thin olivine ribbing on both sides. And then I'm gonna move over and we start getting into just the matrix.
It's super cool, man.
Yep. So those big phenocrysts are kind of what makes this one extra beautiful.
Yeah.
Nice.
That is a particularly beautiful Martian.
And they show up nicely there. Again, crystal boundaries, not so clean, not so crisp. The rest of these things will be subuhedral for their crystal structure. But yeah, hitting that one nice big phenocryst in there was the thing I wanted out of this slide.
Nice.
Trying to move it along slow enough so you can get an idea of the size of that thing.
Yeah.
Without zoom jumping too much. But yep. So yeah, that's a olivine ferric shergottite.
Cool.
There you go, Jen.
Yep.
All right. Hold on one second.
What about 15373?
15373 Lunar.
Lunar. Ooh.
15373 Lunar.
Ooh.
Lunars are some of my favorite slides to make because they seem to be pretty darn hard. So you really don't get much plucking. You get nice edges for the most part. Color-wise, they're not all that colorful in there. You're talking about a lot of plagioclase and stuff in there. So, a lot of first orders. So you got a lot of grays, a lot of blacks, but you can see the crystal structure in there. Slide, and it had a decent amount of melt in it. There you go. This has some of the melt in it, but it doesn't really have the flow structure to it.
Same stone or same?
Well, yeah, it's the same stone.
Wow.
Here you go. Here's some of that melty region right there. You can see the kind of.
Oh, that's.
You can see how much it curves and flows around there.
That's awesome.
That's
beautiful.
That was
really cool.
Yeah, because it's a feldspathic breccia. It's not a melt, but yeah, I mean this thing has some decent melt going on around in this one. So,
would the melty areas of Jikharra 001 look similar, Mike?
You want to look at Jikharra 001?
Sure.
Cool.
Let me pull that up. So that was a slide I finished at like 1 a.m. yesterday.
Yeah.
It has a big clast on the inside, and you're going to see when I put this under the microscope, this thing is like the most vesicular meteorite I've ever seen. Let's find some vesicles. So this is a big clast in the middle, and this is what most of this material looks like. You get to the melt with the vesicles, you start getting these kind of angular little lathy crystals, right? Little needles.
What was the
and look at all those vesicles.
So would those be called quench crystals, Michael?
Yeah, they're probably formed out of a quench, so they melted and they cooled really quickly, and so they're very, very small crystals.
Okay.
What was the class
some
on
of
this
them
again?
actually radial. They have like a nuclei, and they all radiate from a common nuclei. But
Cool.
all those spots in there that are clear where you're seeing through, that's all vesicles.
Wow.
What class is this?
This is a Eucrite-melt breccia.
Oh, okay.
So again, this is mostly pyroxene here, so that's why we're not seeing the more vivid colors.
Yeah, a lot of plagioclase too. A lot of plagioclase in there, which is low order. You really don't see much olivine at all in these things.
Right. Okay.
But as you can see, I mean, this slide is just full of vesicles all over the place.
Wow.
Minus this one large unmelted clast in the middle. So this is what unmelted Jikharra looks like. And this is what melted Jikharra looks like.
Super cool, Mike.
Wow.
Yep. Lots of bubbles in there.
Wow.
What else?
Oued, Namous.
Allende?
Oued, Namous.
Oued, Namous, and Allende. Let me pop the Angrite under there because I already have that out, and I'll let you start looking at that while I maneuver around.
Good.
That's great.
Holy moly.
Yeah,
Oh,
baby.
good God.
That's
Yeah.
the Angrite?
Angrites?
Wow,
Angrite
it looks so different from the other stuff.
Angrites are probably one of my favorite. They got a lot of little needly crystals. We had talked about twinning before. So you can see each of these little needles like looking down towards like the 6 o'clock, about 2/3 of the way down.
Yeah.
You see that dark line shooting through the middle of each of those crystals? That's a twinning plane. Likewise, you got this kind of creamsicle looking crystal down at the 6 o'clock, where it's orange on both ends, and then lighter kind of yellowish, very lemony yellow in the middle. That's also a twinned crystal. And that big hole in there is not a pluck.
Now, there's a crystal at about 2 o'clock that's half blue and half white. Is that another twin?
Yep. Yeah, that's another twin crystal.
Wow.
Yeah, I'll move that around a little bit. I'm still digging for.
Goodness.
This Angrite is really, really unique stuff, and I do have small subgram pieces available. So, notice to the crew.
Okay.
Yeah, and I might actually have to circle back and get a second piece because the stuff that I have doesn't have any of the large olivines in it. So, my slide specimen is lacking. There she is, though. So you got some chondrules in there, right at the dead center. That is a CAI. Oh, no, I'm sorry. Dead center is a amoeboid olivine inclusion. Let me see if I can get the zoom in on that a little bit. Switch with the focus. Let me rotate that too. See if we can get it to show some olivine colors.
Yeah, so these are called AOAs, amoeboid olivine aggregates, and they are, even though they're made out of olivine, they're associated with the CAIs, and I think they're generally considered to be a class of CAIs. I don't know how that makes them different, but in the literature, that's how they're described.
Yep, and carbonaceous, a lot of dark matrix in there. Let's see here. You got there's some nice olivines in there. Let me dump the brightness down because looking through the eyepiece, I'm getting a lot better view than what the camera picking up on.
Yeah,
that's
that's
nice.
cool though.
Yeah, that's the problem with dark matrix.
Yeah, it looks a heck of a lot different through the eyepiece than what the camera is picking up. So when Marissa says, sometimes I color correct it, like right now, this isn't doing those justice as far as the colors. The camera sensor is really taking those and kind of washing them out here.
Yeah, so everybody can understand what I'm fighting when I'm trying to take a picture.
Yeah, it's hard.
Stuff with black matrix.
Well, just as we're using, the lapidary machines in a way they weren't intended, we're using cell phone cameras in a way they weren't intended. They're designed to make selfies when you're out for drinks with your friends, instead of important science stuff like this.
That kind of looks like a dragon.
Yeah, I was just going to say, it looks like a dragon.
That's a CAI sitting right in the middle there.
Cool.
So that's what they look like under the scope. Somebody had Isheyvo on the list?
Yep.
That looked like Godzilla.
That looked like us.
Oh, lead it to the power plant.
Yeah.
So let me refocus. So this is not my slide. This was made by Timur. And he gets glass that I am envious of. The glass he gets is thick and awesome looking as far as being able to have something better to grab onto while you're slide making.
Yeah, Timur is a pretty amazing guy. He makes thin sections by hand with plates of glass and sandpaper.
Yep.
Wow.
No high tech anything.
That's dedication.
Yeah.
So again, this is a lot of these are a little more monochromatic, but it is washing some of the color out. Isheyvo has very, very small chondrules in there. So I just jumped magnification up to 100.
Oh yeah, now we're starting to see some.
Yeah, hopefully you can see the chondrule a little better in there.
Yeah.
But these are very, very small chondrules. There's that looks like it's probably an AOA. Obviously, what you're seeing with the black here is not like magnetite or anything. That's all metal. There's a nice little chondrule in there. But you see, you get a lot of tiny little fragments in there.
Yeah.
And you can see it's, 80% metal?
That's a CHCb, right?
Yes. It's the only CHCBB.
Stuff like this, I hate photographing.
Yeah, and again, like it really does. It looks so much different to the human eye looking through the optic than it does with the camera on there.
Mm-hmm.
You see those two very round chondrules there?
Yes.
Oh yeah.
Isheyvo has very interesting cryptocrystalline chondrules in there, so they quench so quickly they couldn't actually form minerals. They're basically just glassy chondrules.
Cool.
And Isheyvo has a lot of those little, very round, very glassy chondrules in there, like that one kind of towards the center, a little south center.
Yeah, a lot of the very primitive type 3s have chondrules with a lot of glass in them. And glass is, it's made out of the olivine and the pyroxene and such, but it cooled so quickly that it had no chance to crystallize. And so it's just glass. It's amorphous.
This is Viñales we're looking at. We were comparing it to some Chelyabinsk earlier because they look very similar in the hand, crust-wise, everything.
There's that nice thin crust line.
That's crazy. Beautiful. What was next on the list, man?
Somebody wanted Yang's provisional 3, which
yes.
I will.
All right, this one's for Yang. Wow.
Oh my gosh.
So here's the thing. I can't show you the whole thing, but that's one giant chondrule.
I knew it.
Which meteorite is this?
Let's get to the edge. So this is Yang's provisional LL3.
Oh my god.
Oh my
Wow.
god.
There's the edge of it, and we'll trace around it. And then I'll pop to the other camera later and show it to you. So it cuts all the way over there. Yeah, there's a little bubble.
Wow.
So this is a porphyritic olivine chondrule. And in these chondrules, there's a bunch of nucleation sites. So the olivine crystals grow as individual crystals instead of as a stack of plates or other sort of arrangement. And so you get this like stained glass window sort of thing of all these individual olivine crystals that don't have any relation to each other in terms of the crystalline lattice. direction.
Yep. There is another big chondrule that's split in half.
Yeah.
Wow.
So there's the one edge there.
Yeah.
Cutting across the other edge. This thing has got some nice chondrules in it.
Oh, that's cool.
Oh my
Here
goodness.
is a big crazy one right there.
Wow.
Wow.
You can see the center of it is barred olivine, but it definitely has some rimming to it that's porphyritic olivine around the. There's a little partial radial pyroxene there.
Wow.
That's serious eye candy.
Yeah, it's like candy.
Wow.
Yep.
Microscopes open up an entire world to you, and thin sections open up an entire world of meteorites. Thank you so much for joining us on this crew cut. Come back and join us for another one.
Yeah, but if you go back to the Michel-Levy chart, you could see the order, the colors for olivine. You'll get these kind of vibrant yellows at their peak, these vibrant pinks at their peak. You're looking for that row on the Michel-Levy chart in order to figure out what olivine looks like. And it stands out pretty well. Like you see, there's a chondrule down at the 5 o'clock that's also a barred olivine, and it's kind of giving greens and blues. But it's that distinct order that you get with the olivines. After a while, you just, your eyeballs pick them out for what's what.
And so these fluffy cloud CAIs in Allende, we believe, are formed by a gas going to a solid at the edges of the solar nebula. So these are formed at a very, very high temperature, and they're depleted in all of the more volatile elements. And the supreme mystery is, why are these super high temperature things incorporated in carbonaceous chondrites, whereas in the matrix of these carbonaceous chondrites is all sorts of low temperature stuff. So there had to be some mechanism by where the CAIs got formed and then thrown way out in the beyond the orbit of Jupiter to be accreted into carbonaceous chondrites.
Mike, did you pull out the one you made yet?
You really want to see that?
I do.
So
I want to see the progression of how good you've gotten after all this practice.
Here's the thing, and I'll this is like that. This is a learning point. I keep even the majority of my bad slides. So this was a mistake from the start. I kind of doomed myself from failure to start. When you get into slides, don't use a weathered NWA to start with. The weathered matrix just turns to mush and peels off the slide, and it gets difficult. And so this was slide number 1 ever. It's supposed to be about 8 times that large.
Oh, yeah.
But that's what I have left.
Yeah. It's amazing how different the consistency of the stones are. A lot of the more weathered type 3s, the matrix is very, very soft and kind of more clay-like. And some of the other much less weathered ones are really hard and much more agate-like.
Yeah. And so the only thing right on this slide is the label and the edges are polished nicely. Right. So I started off with a 5-minute epoxy. The first time I made a slide, I just took some regular old shop epoxy and used that. It doesn't bond terribly well. It's kind of thick. So you able to get a even amount of epoxy underneath leads to it being uneven, which leads you to grinding off too much. But you know what? Let's take a look at it. This is about, when did I do this? This is probably about 9 or 10 months ago that I've been at it.
Wow.
So
that's a lot of progress.
Yeah. And less than a year.
The difference between this and the Jikharra is night and day. Be honest with you, this is a little thick looking at the colors. the olivines are popping a little too bright.
A lot of second order.
Yeah, a little higher towards the high end of first order than it should be. But like I said, you gotta risk something and start somewhere. So this was it. You can see it's a lot of stained minerals in there. So you can tell it's highly weathered. It was probably like a H5 or H6. There's not much metal left in there, but you can see all that dark staining going on. And there's almost no whole chondrules. It's all just broken fragments.
Wow.
It's still cool to look at, but yeah, you've made a big improvement.
And I keep that slide around specifically to look back on where I came from.